Hello everyone, I'm Mohammad Moghadam, a research assistant professor of Clinical AI Group, Faculty of Dentistry, HKU. And this is the third part of our video series about artificial intelligence in dentistry and oral health. And in this part, I plan to talk about image processing because lots of applications about AI in dentistry and oral health related to this topic. I hope it will be helpful for you. Thank you. Like the previous video series, I don't talk about the mathematics and details about the models. So I try to make things very simple, and the target audience can be some high school or college student or undergrad student or dental or dentist students or dentists who likes to know more about AI in dentistry. Okay, if we want to start to talk about image processing, that would be good to know that computer language. Actually, computer can only understand 0 and 1. And we call this 0 and 1 as a 1 bit. And when we put 8 bits together, we call it 1 byte. So the bit is the most basic unit of information in computing and digital communication. I talked about bit and byte because actually any type of digital information we have, like text, like image, like video, and voice, finally converted to these 0 and 1 bit or byte, and finally save this 0 and 1 into the hard drive. Also in the image is same. Image made by some pixels, and a pixel is the smallest addressable element in image, which each pixel can be shown by 1 byte. For example, if you zoom in into a big image, you can, for example, here we zoom in into this area, we can see that this area can be considered as a 5 by 5 matrix, and each pixel here has a value between 0 to 255, which actually made by 1 byte. If we have a grayscale image or black and white image, we can actually show different level of grayish by the value between 0 to 255 of each byte in each pixel. For example, if the value is 0, the color is completely black. If the value is 255, the color is completely white. And using this approach, we can actually make different grayscale or black and white images. Like here, we can see that on the left, the main image, we zoom in, and the values on the background, and the final matrices. So the image is nothing except one matrix we have, one 2D matrix we have, and we can use these 2D matrices in different analyses. We talked about grayscale image in a previous slide. What about the colorful image? In the colorful image, we have 3 different planes, one blue component, one green component, and red component. Actually, we use these 3 matrices or 3 planes to generate some colorful images. Maybe you ask, actually, here we only have 3 colors. How we can generate different type of color? The idea is exactly what is same as what happened in the real world. For example, if we mix the red and green, we can actually make the yellow color. Here also same. We have different 3 different planes, and each plane in each cell can have a specific value. And by mixing up these 3 values, we can generate different color and maybe 1,000 or even million type of colors. And in the real world, in the actually real images that we can see on the computer, we exactly have these 3 matrices for each colorful images. And in each pixel, we have 3 bytes, and each byte showed the red value, 1 byte for the green value, and 1 byte for the blue component. So for summary, the image is nothing except some numerical matrices. And it's good news for us because we can use these numerical matrices as an input of our machine learning model. and perform different type of image processing on these matrices. Okay, after a brief introduction about images, let's start to talk about some different applications that we can do in machine learning in image processing. Potentially, we can categorize this application into 4 groups. The first one is image classification, the second one is object detection, the third one is object segmentation, and the last one is image enhancement. I will talk about each of these groups in the future slides. Before we go to the details of these 4 categories of application, let's talk about them briefly here. For image classification, actually, suppose that we have some image of dog and some image of cats, and we want to reply to this question that is this image belong to a dog or not? If we want to reply to this question, an image classification model will help us. But sometimes we want to go further. We want to actually find some specific object, like object of dog and object of cat, and show that where exactly in the image happened these 2 objects. So if we want to do this, we need to do the object detection, the second column as here. Sometimes even we want to be more accurate and more precise, and we want to actually extract the specific pixel that belong to a specific object. The exact pixel that belong to the specific object. And in this application, we need to develop some image segmentation model, the third column that you can see here. And sometimes the last one, the image enhancement, we have some noisy image or low quality images, and we want to improve these image using some machine learning model. Let's start with image classification. Image classification is a supervised machine learning model that we have some labeled training data set, which we already annotated all the images. For example, if we want to classify the image between the cat and dog, we have some images of different cat and some images of a different dog, and we already annotated each image, which one is belong to cat and which one is belong to the dog. And then we used this annotated image as the input of the model to train the model. And then after training the model can automatically classify these images by itself. One practical application of image classification is using the model to predict or classify the handwriting values. Suppose that we have some handwriting data sets which has different actually person handwriting that's writes different values between 0 to 9, and we want to build the classifier to classify this value correctly. There is a good database, MNIST database, that different people use this data set to train a good classifier for this application. Here again, as I mentioned, the image is nothing as one matrix, and we can use this matrix as the input of our model to train the model and finally predict the correct value. For example, here you can see a convolutional neural network model, which is used to train based on the MNIST dataset, and we can use this model to predict the value is shown in the image. For example, here the correct output value should be 4. The model here, as you can see, has different layers, convolution layer, max pooling layer, and flattened layer. We don't want to talk about the details of the model in this video, maybe in the future video, but totally we can use this kind of deep learning approach to build the classifier for these kind of applications. Okay, let's talk about some application of image classification. One application we can talk about that is classify dental implant system. Suppose you have a patient and the patient uses different implant from different companies and different brands. And for further, if you want to actually plan some new treatment, that would be good that you know about different brand and type of implant already used in that patient. So one approach is actually you go one by one and check it. And also AI can somehow help you if you have some panoramic image or some periapical image. You can use this image as the input of the model, and the AI can automatically classify different type of implant system. Here I put one paper published recently, and there are also some other papers. This paper used deep convolutional neural network to classify different implant system. Okay, let's go to the second problem or second category of machine learning in image processing, which is object detection. Here the problem is different from the image classification, and we can say is more complicated, because in image classification we just want to say that this image belongs to cat or not, or this image is written 4 or 3 or not. Here we want to find the exact object, and we want to specify actually put one rectangle around that object. For example, here we have one image, and we want to discover different objects like car, bicycle, and dog, and put one rectangle around each of them. So the problem here is more complicated than the image classification model. Object detection algorithm also is very useful in the dentistry and oral health. Suppose that we have a periapical films and periapical images, and we want to detect different tools in these images. It can also be a panoramic image as well. Here we can develop some object detection algorithm to discover different tools for us. Also, this one is another application of object detection, which somehow can be interesting. This work actually tried to use the object detection algorithm to identify different dental instruments. You can see as an input, you can give the image of the instrument, and the output, the model can predict what type of actually instrument is that, and what's the location of the instrument in the image. So somehow it can be interesting for some downstream applications. And object segmentation is the next category of application that we can use machine learning in image processing. Here the problem is more complicated than object detection. In object detection, we just put rectangle around one object that we like to find in the image. But here in image segmentation, we need to extract all pixels belong to a specific object that we like to find. And sometimes in one image, we want to segment multiple objects together. For example, here you can see we want to segment those part of the image that belong to the car, those part of image belong to the person, those part of image belong to the road. As we can see, that image segmentation usually is the more complicated than image classification and object detection. And usually people use the decoder-encoder models. It somehow is a kind of convolutional neural network. And the UNet model is the most famous model that's these days used by the people for image segmentation. I put the link here, and also I put the link into the description of this video. Image segmentation also has lots of application in dentistry. For example, we can develop some image segmentation model to extract the mandibular nerve. Here, for example, one paper used the panoramic images as a training data, as an input of the image segmentation model, and they could develop a model that extracts the nerve, mandibular nerve from the panoramic images. In image segmentation problem, we have two types of segmentation: semantic segmentation and instant segmentation. So what's the difference between these two? Suppose we have the original image on the left. We have one image with 5% on that. If we want to develop an object detection model, so as I've mentioned, we can just develop a model that the output of the model will be a rectangle around each person. In semantic segmentation, we consider all the same object as one object. For example, here we consider all these 5% as one object and label that as a person. But in real world, we can actually be more precise and be more accurate because these 5% are different actually person. And we can go further and do the instant segmentation and label each one of them as a different person: person 1, person 2 to person 5. So these are different between semantic segmentation and instant segmentation. Actually, we have this issue in dentistry application. Suppose that we have actually intraoral scanner images and we want to segment the teeth. On the left-hand side, you can see the output of semantic segmentation. We consider all teeth as one object, and we separated these teeth from the gum. And on the right-hand side, you can see instant segmentation. Because in the real world, these teeth actually, each tooth has its own actually entity, and in the real world, we need to consider them separately. And so definitely instant segmentation is more valuable for us. But instant segmentation definitely is harder to solve, and we need more actually information, more annotated data to solve the instant segmentation problem. For example, these work use the deep learning approach for instant segmentation of teeth. They use the 3D intraoral scanner images as an input of the model, and the output of the model will be the segmented teeth, which can be used for some downstream applications. Image enhancement is another category of application that we can use machine learning in image processing. Here, the input of image is somehow noisy or low quality images, and we try to use some machine learning models to improve the quality of the image and somehow denoising the image. This kind of models has lots of application in medicine and dentistry because sometimes we have some medical image that contain some artifact and noise, and we want to develop some machine learning model to improve the images. As an example, we can use a deep learning model to perform artifact correction on the CT images. And you can see this paper I put here. They used a unit-based deep learning model to perform somehow image enhancements on the dental CT images. Also, another application is enhancing the quality of panoramic image. You can see on the left-hand side, we have the Mandibular image, and on the right-hand side, the output of the model is more actually clear. Okay, we talked about these 4 categories of applications, about image classification, object detection, object segmentation, and image enhancement. For the first 3 categories, most of the models developed till now is based on the supervised learning, and they need some annotated data. So the image annotation is very important in these actually models. I try to talk a little about image annotation in the future slides. Actually, type of annotation that you want to use depends on the final model that you plan to use. If you want to develop an object detection model, it's just necessary just put one rectangle around the object that you want to detect. For example, here, if you want to develop a model that predict the orange from the orange tree, in annotation phase, we just need to put a rectangle around each orange. But if we want to perform segmentation, if we want to actually specifically show which pixel belong to orange, in annotation phase, we need to perform more precisely. Just putting rectangle is not enough, and we need to actually show that which part of the image actually has the orange pixel. And it is same in the dental application. If you want to develop object detection models that, for example, detect the lesion and just put the rectangle around the lesion. So in the annotation phase, you just need to do same. You just need to put the rectangle around those lesions and label them. But if your application is somehow segmentation, like for example for perio disease, you want to find which area of gum has actually infection or inflammation, you need to do segmentation, and you need to specify which part of the image exactly has that inflammation. So it needs more energy and the time to perform segmentation annotation than object detection annotation. To perform image annotation, you can use different tools. For example, here I put a list of tools that you can use. I extracted this list from the Wikipedia, and you can go to the link I provided here, and I put the link in description of this video, and you can see which tool is more useful and is more user-friendly for you to do the annotation. For example, you can see here the environment of LabelMe tools, which is one of the open source tools that you can use to annotate your images. Okay, for summary, if we want to implement some image processing models, first of all, we need to collect some medical images. And then we need to use some image annotation tools that I introduce you to annotate this image. And then we can use this annotated image in different category of problem. We can use it in image classification, object detection, object segmentation, or image enhancement. For some category, like image and enhancement, even we can skip the image annotation, and we can use some unsupervised model to perform image enhancement. The level of annotation depends on your final application and your final model that you plan to use. And it's very important that you clear what exactly you want to do and what kind of model you plan to use, and then go to the annotation phase and annotate your image based on your application and your model. Thank you very much for your attention. I did my best to make a short video, but I think it's a bit longer than two previous parts. If you have any comment, question, just feel free to contact me or put your comment in below in the YouTube comment part. Thank you so much for your attention.